So we're going to start our lesson with the cosine law, with the formulas of the cosine law, when cosine law is used, and how it's used. So yesterday we talked about the sine law, and we talked about that the sine law is used whenever I have an oblique triangle, and I have two angles in any side, or if I have an angle in its opposite side and another side. So with the sine law, I need to have at least an angle in its opposite side so I can use the sine ratio. You guys remember that from yesterday? Now, with cosine law, it's a little bit different. Cosine law, I need either two sides and the angle between them, or I need the three sides to solve for the angle. So the two options that I have here is it must two sides and the contained angle, so that's the angle between them. And in this case, I look for the third side, or I have to have the three sides, and this way I can solve any of the angles. Okay? With the sine law yesterday, we had to have an angle opposite side and another side, right? And I could look for angle B if I want right now because I have two sides and I'm looking for angle B. Or I had to have any two angles and then any side. Okay? It's always easier to identify if it's cosine law or not. Okay? Because looking at cosine law, it's either have to have the two sides and the angle between them, or all three sides. Okay? Now, if it's not cosine law, and it's an oblique triangle, then what do you use? Sine law. Okay? So it's either cosine or sine with an oblique triangle. Can you use primary trig ratios with oblique triangles? No. What do we use primary trig ratios for only? Right angle. Okay? Now, what is the cosine law states? The cosine law states the following. So if I'm looking for side A, it's going to be A squared equal to B squared plus C squared minus 2BC cos angle A. So let's look at this case here. So in this case, I know this side, I know this side, and I know this angle, right? That's the case for me to be able to use cosine law. You guys agree? So two sides and the angle between them. Okay? So, and I'm looking for side A. So to look for side A, it's going to be side B squared plus side C squared. Then I'm going to subtract 2BC times cosine A. So B is known, C is known, angle A is known. Okay? Now in the case I'm looking for B, then what do I use? So if I'm looking for side B, which two sides should be given to me? A and C. Which angle should be given to me? B, right? So I know A and C, and I'm looking, and I know angle B. So that's going to be A squared plus C squared minus 2AC cosine B. Make sense? Now these formulas will be given to you in the formula sheet, so you don't have to memorize them, but at least you have to know which one you're using. Now if you're looking for C, what do? So which one will be given to me? A and B. So it's going to be A squared plus B squared minus 2AB cosine angle So you see that the side here is going to match the angle, right? So you see that the side will match the angle. Okay? At the end of using this formula, you're going to have to make sure that you're going to square root because you're looking for side A. You're not looking for side A squared, right? So at the end, I'm going to have to square root so I can find the answer. Okay? Now, this is the formula if I'm looking for the side, given two sides and an angle between them. If I'm given all three sides and I'm looking for the angle, so basically I'm going to have to isolate for this part of the equation, right? Because I know side A, I know side B, I know side C. I'm looking for angle A, okay? So I have to isolate. The formula becomes like this. So the formula, by isolating, the formula becomes like this. So if I'm looking for cosine A, it's going to be b squared plus c squared minus a squared over 2bc. Okay, in this case, I know all three sides, and I'm looking for the A. And then if I'm looking for B, it's going to be a squared plus c squared minus b squared over 2ac. So you see right here now, the angle is going to match the minus a squared. The angle is going to match this. So what would be for cos C? A squared plus b squared minus c squared over 2ab. Okay? So this is where the match is. Okay? And this comes from isolating the above formulas. This is where they got these formulas. So in this case, I'm looking for cosine C or cosine A or cosine B. Does this answer give me the angle or no? No, it gives me the cosine of the angle. If I want to find the angle, what do I do? Cosine first. So in this case, do not forget to cos inverse your answer. Okay? Because in this case, you're going to get cosine C equals to 0.325. Okay? What is angle C though? And for the previous one, let's put a note as well. And let's say, do not forget to square root your answer. Okay, so let's look at the first example. So the first example is to solve for side B. How do I know it's side B that's asking for? It's because it's low lowercase, right? This is how I know it's actually side B that's asking me. So in this case, what do I know?
A and C.
So I know side A and I know side C. What else do I know? The angle B, which is the angle in between them, right? It's called the contained angle. So I know that contained angle. Now, if I'm looking for side B, so which one of these formulas I'm going to use? So the second one from the first step, right? So it's the B squared equals, right? So I'm looking at it. So the formula is B squared equals to A squared plus C squared minus 2AC cosine angle B. So here's where the trick is. So we're going to enter the numbers in, but then when we're using the calculator, we're going to have to be careful. So in this case, A is 20 squared plus 25 squared minus 2 times 20 times 25 cosine 48. So you have two options here, and it depends on what kind of calculator you have. You either have to do the A squared by itself, the A squared by itself, the C squared by itself, and then 2AC equals B all together, and then add them, or you're going to have to enter everything in the calculator exactly the way you see it. Okay? Or you have 2 times 20 times 25 equals 48. So, your options is to do this. Depending on the calculator you have. If you have a backward calculator, you probably want to do it separate. So, you want to enter this by itself, write the answer. This by itself, write the answer. This all together, write the answer. It's important that this goes all together, otherwise your answer is going to be wrong. Okay? And then what you can do, you can add them or subtract as a whole. So then if I want to do this, 20 squared is 400 plus 25 squared. 625. And then I'm going to do 2 times 20 times 25 times cos 48. So I have to do this all together on my calculator. And that is going to be 669.13. 0.1 is fine, 0.13. And now you can enter them all together. So 400 plus 625 minus 669.13. Now, is that my final answer? I have to square root, right? Because I want to get rid of that square. So to get rid of that square, I have to square root both sides to find my final answer. And then my answer is going to be 18.86, so that's 18.9. This is the side, so it has to be to the nearest 1 decimal, and that is my final answer. So the trick with this is to make sure that you know that whatever is in the square right here, the 2 times 20 times 25 times cos 48, has to go all together, otherwise your calculation is going to be wrong. Are we okay with this? So it's a matter of knowing which law you're going to use, which formula you're gonna pick, right? And it's a matter of plugging the right information in. Now remember, guys, that if your triangle is XYZ, right? And you know angle X, right? When you know Y and Z, you're gonna have to say X squared equals to Y squared plus Z squared minus 2XY or YZ cos X, right? So you're gonna have to be able to manipulate your equation to use the letters that you have. Or you can cross the letters that you have and write them as ABC. Okay? But I mean, you should be able to manipulate the formulas to fit the letters that are given to you. It's not always, life is not perfect, and it's not always gonna be ABC. Right? Are we okay with this? All right, so the second question, we have a triangle, and what is given to us? The three sides, and I'm looking for angle A, because the question is asking me to find angle A, right? In this case, if the question is asking you to solve the triangle, it's open. Solve the triangle, that means solve every single thing, okay? What angle do you want to start solving?
The right one?
This looks like a right angle.
Sorry. Angle A?
Angle A. Could you start solving angle B?
Yes, you could start solving.
Yes, you can, right? In this case, it doesn't matter which angle you start solving, right? Because, I mean, I'm given all the three sides, right? I can pick one of the formulas, solve for the angle that I want. You could start solving angle A. You could start solving angle B. At the end, we're going to end up with the same answer. Okay? All right. Let's solve for angle A here. So what's the formula if I know the three sides and I'm looking for angle A?
First thing.
Cos A equals? So that's A squared, let's call them A, B, no, let's see. Never mind, that's C, and that's B. So it's B squared plus C squared minus A squared over 2BC. So that's going to be 38 squared plus 26 squared minus 30 squared over 2 times 38 times 26. Again, there is a trick in the calculator here where you have to find your numerator by itself, find your denominator by itself, and then do the division. Otherwise, you're going to have a mistake unless you know how to use the calculator properly. So I always tell my students to save yourself from making mistakes. Plug in the top, find the answer, write it down. Plug in the bottom, find the answer, write it down, then do your division. Unless you have that fancy calculator that does the fraction for you. So if I plug in the top, I get 1,220. Is that what you guys got? And if I plug in the bottom, I get 1,976. And then if I divide both of them, I'm going to get cosine A equals to 0.6174. Is that my final answer? Is that angle A? What do I have to do to find angle A?
Cosine inverse.
Cosine inverse. So that's going to be angle A is equal to the cosine inverse of 0.6174. And remember that cosine should be to the nearest degree. So that's about 52 degrees.